Let us suppose we have a cyclobutane and then there is a CH2 positive coming out. Okay, so what can be the reactions for this? So please write the question. Write the major products for the following. Write major products for following. So let us suppose you have something like this. Wait a second. CH2 and then there is I. Okay. And we are doing a reaction like this with aqueous NaOH. Okay, so what are we expecting? We are expecting that this I will leave and OH will add on, but it will not happen like this. The first step here, it will be a carbocation. The formation of carbocation will take place something like this. Cyclobutane, CH2 positive. Now, once you have made this carbocation, what will happen? There will be a breaking of bond. Of this bond will break, right? This bond will break. And what you will be getting? You will be getting negative charge, sorry, CH2 positive here. Okay, and both the electrons of this bond will move to this carbon atom. You will get a negative charge here, you get a positive charge here. Okay, now then this negative charge, it will attack on this carbon atom, and then you will form a carbocation like this. I'm making the new bond with the blue atom. Okay, so once this positive charge, it was a positive charge. As soon as a negative charge attacks here, it will become neutral. So this CH2 has become neutral, and this positive charge, which was in this carbon atom, it will be intact like this. Okay, and then further, what will happen? The OH will attack, and you will be getting on this carbocation, the OH will attack, and you will be getting OH on this carbon atom. Is that clear? Yes or no? Please tell me. Each step. What is happening in each step? Yes or no, guys?
Yes, sir.
Yes, sir.
Let me know when you are done writing this. Done, guys? Yes or no? Okay. Just let me know if someone is writing, okay? No one is writing. Okay, so I will be asking you a few questions here. Now, what you have to do is you will make the carbocation only. Okay, the first carbocation like this. You'll make this much, and then send it to me. I think you can, all of you can do this much. Yes or no? Very quickly. Yes or no? Hania, Heshma, Khalid, Khalil, guys, please tell me.
Yes. Yes, sir.
Yes. Yes. Okay. What about others? Can I get a yes, sir, please, at least? Yes, no? Okay, fine. So what you have to do? You just draw the carbocation. Okay, you just draw the carbocation. Then we will tell how to do it. Please write. Number 1. Uh, okay. Okay, you will not do anything. I'm writing the reagents also, but you will not do anything. You will just make the carbocation, nothing else. Okay. Write these 3.
Sir, before this, did you give anything?
Before this, we did something. This one got disconnected. First write this. First write this. You have to just draw the carbocation. Okay, Nabil.
Yes, sir.
Okay, you can draw just the carbocation. Okay, the first step, no rearrangement, nothing. Simple carbocation. You remove the halogen atom, and on that carbon atom, just put the positive charge. As simple as that. Okay.
Sir, do we have to send you?
Yes, on WhatsApp. Again, Samaira. I want to say this again. What I'm going to say, tell me, Samaira. Something I have pointed out many times. Samaira, are you there?
Yes, sir.
What would I say? Tell me.
That the that plus star should be on the carbon.
That is fine. That is on the carbon only. Something other than that. You look at this bond that you have made now. This red bond that I have made right now. And look how you have made that bond. Do you see the problem? Yes, Samira? Can you please cut it, whatever you have drawn, and make it again? Remake it in a better way with a better representation. Samira, please.
Okay, sir.
Okay. Same with Saf. Saf, do you see a difference on how I have drawn this bond here with CS3 and how you have drawn? Saf, can you see that? Muhammad Saifullah.
Miner slowly appears. He realizes that it is a ghost of a dead miner. They are staring at each other, and it is a shocking feeling. But he accidentally pulls the plug. The lights goes out, and the projection of the miner disappears. Since he has
I
proven
can't
that the
hear
light
you.
bulb allows him to see the other world, he is going to use it to fulfill his long-held dream. He upgrades the bulb to a mobile version and then goes to a haunted house alone. In the house, he found a book on the ground and is turning the pages by itself. He slowly turns the light on, and a straight puppet suddenly appears in front of him. He says hello to the puppet, and the puppet waves back at him as if it has a soul.
It's a Kindle reader or something. How many of you are interested in what Saifullah is reading or listening to? Raise your hand. How many of you are interested in knowing what Saif is reading or listening to? Yes, Saif, what are you listening? All of you are.
Nothing, sir.
Nothing? It was something. Tell us. What was it?
My
Hmm?
brother was showing me something.
Your brother is showing. I am showing you something. That is not important. Your brother is showing you something. How old is your brother? What does he
He's
do?
about 13.
What? Oh, 13. What
He
does he do?
just showed me a joke.
Just showed me a joke. Okay. Fine. But you see the answers. Your answers are a joke, by the way. You see the bond that you have. I was also showing that only. You see the bond here? How you have drawn this bond? Saf?
Yes.
Does it look good? Or does mine look good? Tell me. Which one is better? What do you think? Which one will the teacher like? Saf?
Yes.
What? Yes. Which one will the teacher like? Yours or how I have drawn here?
You
Tell
mean
me.
the bigger bond you were asking?
Yeah, exactly. You have to
Okay.
branch it out clearly, you know? Otherwise, how will the teacher know that it is
Okay,
a
sir.
bond? Okay.
Mm.
Khalid is correct, and yes, correct. Khalid, correct, everyone. Okay. And okay, Nabil Ahmed, your answers are also fine, also correct. Not fine, they're absolutely correct. And Hishma, wait a second, Hishma. Yes, Hishma, very good. Correct, very good. And Salman, first, second, third. Yes, very good, correct. Okay. And whitener. क्या फर्क हो गया समायरा whitener से? Again, that bond is still so small. It is not also visible, huh? Samaira, I
Yes,
asked
sir.
you to cut it, na? Cut it, ऐसे, like this. Cut it. No whitener. Okay, Khalil. Yeah, very good, correct. Fine. Okay. Now, all of you have drawn this. I'm going to draw this again. There is CS3 and there is a positive charge here. There is iodine. Oh, sorry, there will be a positive charge here. CS3 here. Positive charge here. Okay. Now in all of these carbocation, the carbon atom with positive charge, I'm just marking that out in green. So this is the carbon atom here, this is the carbon atom here, this is the carbon atom here. So just look adjacent to this carbon atom, okay? Just the next carbon to this. Is there any 3-degree carbon next to the carbocation? Minashi, do you see a problem in how you have drawn the carbocations? Right. All the first one and the second one also. So you see here, if you add a positive charge here, this would translate to, let me tell you, what will this translate? This will translate to CH3, CH, CH3, CH, CH3, and will translate to CH2 positive, which is not right. Okay. So you will not make a bond and then positive charge. You will just remove the Br with its bond. Okay. If the Br is going, then there will be no bond. Okay. We'll remove the bond also and then put the positive charge on that carbon atom where the Br was attached. Okay. Hania has sent me now. Hania, आपने भी same mistake किया है. Hania.
Yes, sir.
You see the mistake that you have done?
Yes, yes.
Please cut it. Cut it का मतलब whitener कोई नहीं इस्तेमाल करेगा. You will cut it like this. Okay. So when you are revising, you must know what mistakes you do. You know who can use whitener? Okay. Just a caveat from here. Whatever we do, it is getting recorded every time. Yes or no? All of the things are getting recorded correctly. Whatever good we do and whatever sins we do, whatever bad things we do, it gets recorded. But for the sins, you know what? For the sins, if you repent, what would happen if you repent? Whatever the sin you have acquired, the Lord will cut it off, right? They will not, or rather, the sin, they will not be counted. Okay, that is one thing. That is one thing. But if you repent, not only the sins will not be counted, the sins will be erased from your record book also. Okay. So don't play God here. Okay. Don't play God here and whitening up your sins. Just be a human and like a human, cut all of those mistakes. Okay. So that you remember it. So that you remember it. Is that clear, everyone? Yes or no? Please tell me. Is that
Yes.
clear?
Yes.
Yeah.
Yes.
Okay. Very good. So when you repent now, not only the sin doesn't get counted, even the sin is erased from the record book. Okay, fine. Chaliye. Okay, Samaira has sent me once again. Yeah, good, Samaira. Very good. Okay. Now, what I'm asking, my question is there any 3-degree carbon adjacent to the carbocation? Tell me for the first one, yes or no, in the chat, please. All okay. Is there anyone who has not understood the question? Please tell me, or if you have any doubt in how you have understood it. Okay, fine. I think all of you have understood. So please answer for the first one. Is there any 3-degree carbon adjacent to the carbocation? There will be always 2 carbon atoms adjacent to the, here you will see in all of these questions, there will be at least 2 carbon atoms adjacent to the carbocation. You point out on those 2 carbon atoms and tell with what is the degree of those carbon atom. Don't answer just by looking. Okay, don't answer just by looking. Move your hands and tell me. Move your hands and tell me. You see, these are the things that will haunt you. Okay, it's not that rearrangement of carbocation that is difficult. These are the small things which are difficult. Okay, so rearrangement of carbocation, a very big topic. Okay, it's a very big topic. It's very difficult. I don't know how to move the bonds. I don't know do. But if you boil it down, what you have to do first of all, make a carbocation. That is easy, right? Then what you have to do? You have to identify if there is any 3-degree carbocation adjacent, if there is any 3-degree carbon atom adjacent to the carbocation. Now again, this is also a very small thing. You have to just identify. But people will do mistakes here only. Okay, so let me see how many of you have answered. Oh, quite less, huh? Yeah, so Hishma has not answered Hania. Hishma, did you understand the question? Hishma, did
Yes,
you
sir.
understand the? Yes? Okay, fine. So please answer me. Yes or no in the chat. Okay, and who else? Hania has not answered. Hania, did you understand the question? Hania, did you understand the question?
Yes.
Yes. Okay, fine. So answer me. And who else? Nabil Ahmed, I can see. Nabil Khan. Nabil Khan, did you understand the question?
Yes, sir, I understood.
You understood the question. Okay, fine. It's Samaira answered. Sorry to say this, Salman, but I'm not asking about the angels here that you have to believe, right? I'm asking about something that you can see. So tell as a matter of fact, yes or no. Okay, Salman. Yeah. It's not a matter of belief now. Salman has answered, yes, I believe. Okay, who else has not answered here? Khalil has answered. I think everyone has answered. Okay, fine. Okay, so can all of you mark the carbon atoms as 1 and 2 or something, which are adjacent to the carbon? I'm doing this for the first one. For example, this is a the carbon atom adjacent to the carbocation, and then this is also a carbon atom adjacent to the carbocation. Can you do this in your paper and tell me the adjacent carbons? Can all of you can do this now? I hope you are understanding what I'm asking you to do. So you need to mark that. Okay, just circle it. I mean, circle. Circle it. Circle it. You don't have this type of pen, so you will circle this like this, and you will circle this carbon atom like this. Okay, and then say this is the first carbon atom that is adjacent to the carbocation. This is the second carbon atom that is adjacent to the carbocation. Okay, chaliye. Or rather, you will write the degrees here. So I hope you can easily say that this is 3 degree. This is 1 degree. I don't know what else you guys were seeing. So I need to. Nabil Khan. Nabil Khan. Can you hear me?
Yes, sir.
What did you see? I asked you, na, is there any 3 degree? Can you see that there is a 3 degree carbon atom adjacent to the carbocation?
Yes, sir.
Okay, so you saw that as the adjacent carbon atom, or what happened? Why did you say no? There is no 3 degree carbon atom. Tell me. And where did you have the problem?
There is a 3-degree carbon.
But you answered no. I want to know, why did you answer no? Huh? Did you put up a pencil like on that carbon atom and counted whether it is 3 degree or 2 degree? No, na?
Yes, sir. Yes, sir. Now I can.
Okay, fine. Okay, so what about other people? Like why? Minashi, tell me what happened. There two things can happen here. Okay, two things can happen here. Either you can't identify the adjacent carbon atom, or you are not able to identify the 3 degree carbon atom. Okay, whether it is 3 degree or not. So Minashi, tell me, where did you have the problem?
I consider that third carbon.
Sorry, what?
The carbon
You
cation I considered.
You considered what? Sorry, can't hear.
The carbon cation.
Carbocation. Okay.
Yeah.
Acha, you did not. Okay. What did I ask? You understand now? Question now?
Yes, sir. Yes.
Acha, okay. You thought that I was asking, is the carbocation 3 degree?
Yeah.
But that is not my question. Okay, fine. My question was right. You read it wrong. Can I say that, Minashi?
Yes.
Okay, fine. Read it properly then. Okay, Samaira also I think answered no. Samaira, You thought I am asking whether the carbocation is 3 degree?
No, sir, I thought it was 2 degree.
You thought this was 2 degree.
Yeah.
Why? Okay, but you see now, na, it is 3 degree, yes or no?
Yes, sir.
Okay, fine. You see it now. Okay, fine. Who else has answered no? Mohammed Saf answered no, but then he changed it to yes, I guess somewhere. Yeah, he's changed it. And most of you then answered yes. Okay, fine. Now, can I get an answer for the second one? Is there any 3 degree carbon adjacent to the carbocation?
Yes.
What about others? Can I get a yes or no, sir, from everyone?
Yes, sir.
Yes, na? Okay, fine. Fine, I'm getting yes from everyone. Okay, what about the third one? Is there any 3 degree carbon adjacent to the carbocation?
No, sir.
Who said no? Who said no? See this? This is 3 degree, right? Yes or no? This is 3 degree. Who said no? Okay, fine. Now, in all of them, whenever you have this case, now if you have any carbon atom, just adjacent to the carbocation, and there is what? And there is a 3 degree carbocation adjacent to the carbocation. So there is a 3 degree carbon atom adjacent to carbocation, then there will be always rearrangement. Okay, there will be always rearrangement. Okay, and whenever you have 3 degree, then what will happen? Two things can happen. Either hydride shift will happen, or if there is a ring, then what will happen? If that means C, or if the 3 degree carbon is on the ring and carbocation is outside the ring, then ring expansion will take place. Then ring expansion. Is that clear? Yes or no? Please tell me. Write this the point down. Hydride shift. If there is 3 degree, then it will be hydride shift or okay. Now in the second one, see for the first one it is easy that it will be hydride shift here. Okay, so hydride shift will take place from here. This carbon has 3 bonds, so there will be one hydrogen here. This hydrogen will move and it will make a new carbocation. Okay, so that is another thing. But look at the second structure. Okay, look at the second structure and tell me in the chat whether it will be hydride shift or ring expansion. We'll write H or Re. What will take place? What you have to see here is that if the carbocation is outside the ring, then only ring expansion will happen. Okay, so all of you will tell me. Otherwise, what will happen? Hydride shift will happen. So tell me, for the second case, what will happen? Hydride shift or ring expansion? What you have to see is the carbocation outside the ring or not. If the carbocation is outside the ring, then only the ring expansion will happen. Otherwise, it will not happen. H or Re, what will happen? Only Khalid has answered. Samaira has answered. Okay, Minashi, good. Waiting for others. Hania, good. Yes. Correct, Heshma. Okay, Nabil. No, Khalil. Look at the criteria, Khalil. Yes, Saf. Correct. Khalil, can you please turn the mic on?
Yes, sir.
You see that the carbocation is included in the ring, right? In the second question.
Yes, sir.
Okay, so it will be hydride shift here also. Okay, so you have 3-degree carbocation, and there will be a hydrogen atom somewhere here. This hydrogen atom will shift here, and you will be making a. So when the hydrogen will shift here, this positive charge will go away, and this CH3 here, and this carbon atom, 3-degree carbon atom that you have identified, will get a positive charge. Now, in the third case, you tell me, hydrogen or ring expansion, what will take place? Hydrogen hydride shift or ring expansion? Correct, Salman. Correct, Hishma. Correct, Minashi. Yes. So you guys are answering it correctly. So what will happen? Just this bond will shift here. This bond will, rather on this carbon atom, it will go to this carbon atom. So the best way is to number it 1, 2, 3, 4, 5, and 6. Okay, so we have here 6 atoms. So the bond between 3 and 6, it will go from 6 to 2. Rather than attaching on this third carbon, what will happen? It will go to 6 to 2. So now it is 4-membered ring. If it will expand, what it will become? It will become 5-membered ring. So make the 5-membered ring like this if you want to make it directly. Okay, and then what you will do? In the 5-membered ring, you will say that, okay, fine, this is 2. Start with 2 because 2 is getting attached here. Okay, and 2, 3, 4, 5, and 6. So you have made a bond with 6 and 2, and you also see that 2 is attached to 1. So there will be a carbon atom like this. We attach to 1, and what will get the positive charge? The positive charge will be on this 3, this third carbon atom here. Okay, and in the next step, all of you know what is going to happen. In the next step, whatever the nucleophile is, it will get attached to that positive charge. Just decreasing its size so that I can make the structure here. When the hydride shift will take place, this gets the hydrogen atom. So, but we don't show the hydrogen atom. That is why we'll just write here CH3 and a positive charge. Okay, chaliye. After this, you all can make the product, yes or no? So from here, the CN will attack. From here, you will attach the OH, and from here, you will attach the NH2. Okay, please, all of you can make the product, yes or no? Ania, Hishma, Khalid, Khalil. Yes, and Nabil, Samara, all of you guys? No.
Yes, sir.
Yes, no. Samira?
Yes, sir.
Okay, okay. You have to attach the nucleophile on the positive charge. That is it. Waiting for your answers, guys. Okay. See, we have spent a lot of time in ring expansion and rearrangement just for that one question if CBSE gives you guys. Okay. So you don't feel in a very, do we say, you don't feel so much uncomfortable in the exam. Okay. So please remember these things only. Okay. The questions that you need to ask yourself while you are doing the ring expansion and these things.
Sir, I wasn't able to hear you last minute. Could you say what we're supposed to find?
You have to write the product. We have here rearrange. Sorry, here we have reagents. Reagent. Okay. Here we have the reagents, right? So, and we have done this reagents. Yes, Khalil, very good, correct. You understood this rearrangement, Khalil? Yes or no?
Yes, sir.
Okay. But you will forget, all of you will forget, okay? So don't remember these things. Remember these questions. I hope the questions are easy to remember. Okay. Now the questions will, you ask yourself some questions and they will push you to do the right thing. Okay. So ऐसे कुछ रटने की कोशिश मत करिए, but हाँ, if you want to remember, then you just remember these questions. Is there any 3 degree? Then only what will happen? Then only you will be doing rearrangements. Okay. And if you're confused between ring expansion and hydride shift, then just look. If the carbocation is away from the ring and the 3 degree carbon that you are looking at is in the ring, then there will be a ring expansion. Otherwise, there will be hydride shift. Okay. After this, I will write one more thing. Only Khalil has sent me answer. Okay. Yeah, Nabil, correct. Khalil के answer में Khalil, sorry. For the first one, see, you have done a mistake, na? See, आपने कुछ गलती कर दिया वहां पे, देखिए. Get it, Khalil? Yes, Khalil. Look at the first one. Do you see your mistake in the product? Okay, fine. Correct it, okay, Khalil? Correct. Ishma, correct. Samaira. Correct, Samaira. Saifullah. Okay, fine. You have done 3 only. That is 3. I looked at 2 degree. Okay, fine. Correct, Saif. Minashi. Very good, Minashi. Correct. Khalil, you have corrected. Okay, fine. Good. I'm waiting for some other people also. Khalid, Salman, Hania, you have not sent me answers. Yes, Hania.
Yes, sir, answer.
Okay. ऐसे नाम ना लेना पड़े ना, बताइए ऐसे कैसे चलेगा? And I'm not going to write the answers here, okay, by the way. Okay. Now you will write. So see, if there is 3-degree carbon adjacent, then what will happen? Hydride shift, okay? Then you will write methyl shift happens if there is a 4-degree carbon adjacent to carbocation. So for example, if you have Br here, and you have here CH3 and here also CH3. So the carbocation that you will make, CH3, CH3. So this is a carbocation. And this carbon atom, it is what? 4-degree, right? It has 1, 2, 3, and 4 atoms. So all of these are what? CH3s only. All of these are CH3. So any one of the CH3 will come here. It is known as 1,2-methyl shift. In general, it is known as alkyl shift, but here specifically it is 1,2-methyl shift. And one CH3 will go here. So this CH3, it has migrated. So I will make the new bond as a blue. Okay, so this is CH3 that has shifted here. So this carbon atom will get neutralized, and the carbon atom from where the CH3 has shifted, it will get a positive charge. Okay. For example, we are reacting this with, let us say, KCN or something. Then we will be getting okay. Yes, Khalid, correct. Hania, looking at your answers. Hania, can you please turn the
Yes,
mic
sir.
on? You have not made all of these things, no? Yes, Hania, tell me. Yes or no?
Oh, okay. I'll
Hmm?
send, sir. I've
No,
made
no,
them.
no. You have made them. Okay,
Yes.
fine. Then look at the first answer. Do you see the mistake? Look at the first one.
Yes.
Okay, then just correct it.
Sir, could you scroll down a little bit?
Sure. Done, guys? Can I move on? Yes or no, please tell me.
So 1 minute.
Okay.
Sir, could you say what are the products for second and third one also, sir?
Sorry. What are the
The products for second and third one.
products for second and third one? You sent your answers, no? I will tell you. You send your answers. Your answers are fine, correct?
Okay, sir. Thank you, sir.
Okay. Done, everyone? Yes or no, please tell me. Oh, what happened? No.
And done, sir.
Done, no? Okay, fine. So I'm just writing a conclusion. Please write this conclusion with me. What you have to look? Look at carbon adjacent to carbocation. Okay. So there can be many cases. If it is 1 degree, then nothing will happen. If it is 2 degree, then also nothing will happen. If it is 3 degree, then what will happen? Hydride shift. Okay. But if it is 3 degree and on ring, then what is going to happen? Ring expansion will happen, right? Then what is going to happen? Ring expansion as well be happening. And even if ring expansion, but please you will remember that 3 will change to 4, 4 will change to 5, right? And 5 will change to 6. And again, 6 is the most. You cannot go, you cannot expand the ring after 6. Okay, please remember this. Now, again, if it is also 4 degree and on ring, then also what is going to happen? So for example, you have some option like this. So this will change into positive charge here, right? Now again, what will happen? The ring expansion only will happen. Okay, the rings will expand like this. So here you will get the positive charge here like this. Okay, 3 degree. Now the positive charge will be, okay, sorry, not here, rather it will be here. 1, 2, 3, 4, 5, 6. So it will be 7. So you can start with the just 2, 4, 5, 6. And then you have, wait a second. So always a good idea to first map it. Correct. Okay, fine. So this will be 2, this will be 3. This is 2. Chat the positive charge. It is making a bond with 3, 4, 5, 6, and this is 7. And then you are having 2, no, 2 is getting bonded with 4, my bad. 2 is getting bonded with 4, 5, 6, and then this is the 3 here. 2, this is 3, yeah, 3. This is 3 is bonded to 7 and 2 is bonded to 1. And you are getting a positive charge on this 3 atom. So this is also 3 degree. So even if you have 4 degrees, so what I wanted to just say is that this atom here, it is 4 degree and on the ring, and it is what doing, it is doing a ring expansion. So if it is 4 degree on ring, then also it will be ring expansion. Okay. If it is 3 degree on ring, okay, fine. If it is just 4 degree and on its own, then what it will be happening? There will be a methyl shift. And CBSE will not give you other than methyl shift. There can be other alkyl shifts also, but that is not probably not going to happen. Okay, any kind of, so CS3 can also migrate, C2H5 can also migrate, but these cases they will not give you. Okay, so they can give you at least till CS3. वो भी अभी तक हुआ नहीं. Never has, CBSE has never asked this type of question. Okay, fine. So just write this thing down. Look at the carbon adjacent to carbocation. If 1 degree, then nothing will happen. 2 degree, nothing will happen. 3 degree, then hydride shift. If it is 3 degree on ring, then it will be ring expansion. Now this carbocation can only be 1 degree or 2 degree. If it is already 3 degree, then nothing will happen. Okay, it is 1 degree or 2 degree. If it is unstable, then only the rearrangement happens. If you are going from 3 degree to 3 degree, there is no need. Done, guys? Yes or no? Please tell me. Write the next topic, elimination reactions. Okay, elimination reaction. Write with me. The reaction in which the reaction in which atom or group of atoms, okay, atom or group of atoms of the substrate are removed from adjacent carbons in the presence of a base to form an unsaturated compound is called elimination reaction. Okay. So in elimination reaction, basically what happens? You have carbon atoms like this. Each carbon atom with 4 bonds. Let us say you have X here, you have Y here. Both this X and Y get eliminated. Now, since these 3 carbons are, so carbons are having only 3 bonds, and this gets eliminated, and there is a pi bond which is formed, and XY. Okay, like this. So this is the basics of elimination reaction. Okay, this is the basics of elimination reaction. There are 2 types of elimination that can happen. Please write types of elimination reaction. One is known as E1 and the other one is known as E2. Now in E1, it is what? It involves 2 steps. So E1 it involves 2 steps. So please write step 1. Just like SN1, E1 it also has 2 steps. So in this step, what will happen? There will be hydrogen attached to carbon. The next carbon atom will have a halogen atom. Okay, wait a second, let me write it like this. Hydrogen and halogen here. Now, in the presence of a, what will happen in the presence of a base? This X will cleave first like this, and will make a carbocation. Okay, it will make a carbocation. The step 2 is attack of the base, okay, or the cleavage of the CH bond here. Step 2. Step 2, what happens? There will be a base. So I'm showing that B. Okay, so this base will attack this hydrogen. This hydrogen will give the electrons here to form a bond. That is a pi bond, and you will get. Okay. This is something that you will be getting. Step 2. So first, what is happening? Cleavage of CX, and step 2, cleavage of CH. So again, why this is called as E1? Because this is going to be slow. This is going to be the rate determining step, and in this also the rate is determined by the substrate concentration only. Okay. Now E2 will be, in this case, both of the things will be happening in the same step. So there will be a base. The base also have is electron rich. It will be attacking on the hydrogen atom of the substrate. So this base will attack on hydrogen. Now hydrogen, it is forming a bond with base, and that is why it will be breaking the CH bond. Now, if the CH bond is going to break and it is going to form a pi bond, this carbon atom should also break a bond, because it cannot have the valency of 5. It cannot have 5 bond. And at the end, what you will be getting? A carbon-carbon double bond. Okay. Plus X will leave as X negative, and the base will get the hydrogen like this. Okay. You just keep in mind, it is similar to SN1 and SN2. That is why you have discussed this. Otherwise, it is not present in your syllabus. What they have said that this is beta elimination. What does beta elimination means? It just means that in both of the cases, you can see this is the alpha carbon which is having the halogen atom. This is the alpha carbon which is having the halogen atom, and the hydrogen from the beta carbon, which is at alpha, adjacent will be beta. Here also this is beta. Now this is alpha. This was beta. So this beta hydrogen is also getting eliminated. That is why it is known as what? It is known as beta elimination. It is also known as beta elimination. Okay. So this is a beta elimination as per your NCERT textbook. NCERT, they have not classified into E1 and E2, but it is similar to SN1 and SN2. So keep that in your mind. It will not be asked in CBSE. Done, everyone? Yes or no? Please tell me.
Sir, can you show what you wrote before this? The example.
Done, na, Khalid?
Yes, sir.
Done, guys? Yes or no? Please tell me. Is everyone done?
Yes, sir.
Okay. All right, next. So there are a few examples of elimination reaction that you are going to study in the school 11th standard. Some examples I will write here. Dehydrohalogenation. So in this, what will happen? Halogen atom will be removed, and from the adjacent carbon, hydrogen atom will be removed. Okay, so dehydrohalogenation. Second is known as dehydration. Now, in dehydration, what happens? Removal of H2O. So how will the H2O be removed? So from one carbon atom, you will remove the OH group, and from the other carbon atom, you will remove the hydrogen. So as soon as you see OH, you should know that this will be coming in the next chapter, that is alcohol, phenols, and ethers. That is why the like haloalkanes and haloarene takes a lot of time, because we are revising the 11th standard stuff also, stability of carbocation, stability of these free radicals, etc. Markovnikov. And then here you will know about the Sedzev rule and etc. But all of these things will be applied in the next chapters. Okay, so the next chapters will be very fast. Third thing is dehalogenation. So what you can do, you can also remove two halogen atoms from vicinity. If you have adjacent halogen atom, then that can be also removed. You will see this reaction in this chapter only. Okay. First of all, you will write the topic. Dehydrohalogenation. Okay. For this, you will write with me. When alkyne halide reacts with alcoholic KOH, then it undergoes dehydrohalogenation. And gives alkene. Okay, and gives alkene. So we'll write the reaction like this. We have CH2, double bond CH2. No, sorry. CH2 single bond CH2. This carbon also has a hydrogen, that is CH3, and this carbon has, let us say, chlorine. Okay. And if I react this with alcoholic KOH, then what is going to happen? This HCl will be removed, and you will be getting CH2 double bond CH2. Okay. As simple as that. So the very surface type of knowledge that you can have about any reaction is what are the bonds that are breaking. So CX bond is breaking, CH bond is breaking, And what is happening? C, double bond C, the pi bond is formed. Okay, pi is formed. Okay, so this is the most basic thing that you can remember from a particular reaction, that insight that you can gather from a reaction. And also remember, this is alcoholic KOH. Okay, please remember, this is also a question that we will consider in the next class. Why alcoholic KOH, it gives you elimination, but aqueous KOH, it gives you nucleophilic substitution reactions. Okay. Done, everyone? Yes or no? Please tell me.
1 minute.
Done, guys? Yes or no? Please tell me. Done, na?
Sir, starting what you are given, can you just show 1 second?
Starting
Yes, sir. Yes, sir.
from the
Yes, sir.
starting of the class.
Yes, sir. I had come 5 minutes late.
This one, this is from your previous class.
So just little down, sir. Light major products are found.
This part. Take
Okay,
a
sir. Thank
screenshot.
you, sir.
Took a screenshot.
Good, sir. Yes, sir. Thank you, sir.
ठीक है. Now let us see what is going to happen if I have something like this. CH3, CH, CH3. And we have a Br here. Alcoholic KOH. If I'm reacting, then what can happen? See, I have a hydrogen here also in this carbon also, and there is a hydrogen in this carbon also, right? So we can break. Okay, obviously, first of all, what you will do, you will identify the carbon atom where you have the halogen. So you must say that this bond is going to break for sure. Now, whether I should break this carbon CH bond or this carbon CH bond, then you will say, sir, we can break any one of them. Why? Because both of these are equivalent carbon atoms. I hope you remember how to identify equivalent carbon atoms, right? So both of these are what? Equivalent. So I can break any one of them and I can make, say like this, CH. If I break this hydrogen bond, it will be CH2 and a double bond will be with the second carbon and, sorry, and here you will have CH3. This will be CH, right? Yes or no? Any doubt here? I hope you don't have any doubt here in this equation. Yes or no? Please tell me. Is there anyone who has doubt in this? Please raise your hand. Samaira, Salman, Minashi, Khalid, guys. Yes or no? No doubts?
No,
No
sir.
doubt in this.
No
question,
doubt,
right?
sir.
But oh, bhai sahab, someone is like, we're going to sleep. Okay. But if I have something like this, let us say, yeah, BR. So I hope now you can see that. Okay, turn the mic on and tell me 1, 2, 3, 4. Which carbon atom has halogen atom here? Which carbon atom has halogen atom? Tell me. Which carbon atom? 1, 2, 3, or 4?
2.
All of you can see 2, na? Okay, fine. That means this bond is obviously going to break. But the other question is, will the pi bond be formed? Will the pi bond will be formed with this carbon atom or this carbon atom? That is the question. Okay. So now what you will remember, I'll draw the product, the major product. Okay. And the reason we will be giving in the next class, it is a Sedzeff rule again. If I will treat this with alcoholic KOH, then it can make two products. Either it can have a double bond with this carbon atom, or it can have a double bond with this carbon atom. So I will make both the products. To make the green one, there will be double bond like this. Okay, so in this BR bond has been, wait a second, not a good structure. Okay, and the red one will be like this. Now, here we have the double bond here and here. Here we have the double bond here and here. Here the double bond is attached with only one alkyl group. Here it is attached with two different alkyl groups. And if it is attached with more alkyl group, that is going to be more stable, and that is why this will be major, and this will be minor. Okay. So at this end, what you have to see, which structure has more alkyl group around C double bond C. Okay. Once you make you will make both of them. Which structure has more alkyl group? The answer to this will be the major product. Here we have two. Here we only have one alkyl group. See, this is alkyl group. Here we have one alkyl group. The other alkyl group is there. Okay. So the number of alkyl group is mattering, not the number of carbon atom in the alkyl group. Please remember. Here also we have, sorry. Here we have only one alkyl group, but here we have two alkyl groups. That matters. Is that understood how to make major and minor? Yes or no? Tell me.
Yes, sir.
Yes.
Write this down. So if you can see that I can start with alcohols, then I can move to alkyl halide. Then now I can move to alkene also, right? So I hope you have some picture of the conversions that we can do. Yes or no now? Tell me. Can you see the conversions happening? 3 step at least, 2 reactions at least. Alcohol say we can prepare haloalkane. From haloalkane we can prepare alkenes, right? So keep in mind the conversions that you can do. Done, everyone. Also, we can go from alkane to alkene via haloalkane. Done, everyone. Yes or no? Please tell me.
Yes, sir.
Okay. So write a question. Write the. Wait. Write a note first. The following reagents can be used for dehydrohalogenation. Or the same thing is beta elimination. You have seen alcoholic KOH. You can also use alcoholic NaOH, same thing. Alcoholic NaOH. Second reagent will be sodium alkoxide with any alcohol. Oops. I always forget the third number. I don't know why. NaNH2. It is sodium amide. Done, guys? Yes or no? Please tell me. No. Okay. So let us say you have a question like this. Okay. So first of all, you will identify the carbon atoms which are having halogen. Okay. So obviously this bond is going to break, this bond is going to break, and this bond is going to break. That is for sure. Now we have to look at the adjacent carbon atoms. So either this or this will break. Okay. Here also this will break, or you will have this bond which is going to break. And now all of these CS3s are same. That is why nothing will happen here. Okay. You will be getting the same product. You can remove any of the hydrogens and you will get the same product. Look at the first one. Tell me, are both of these identical or non-identical? The first question. The blue and the green, they're identical or non-identical?
Identical.
Identical, right?
Identical.
Yeah, so identical. So here also you don't have to do anything. Anyone can break. Okay, now in the second one, you tell me. Yeah, correct. I'm very happy you guys can identify identical or identical now. Very good, guys. Okay, now you tell me for the second case, where will I get the pi bond? The blue or the green? Can you answer in the chat? Please don't write anything. Just answer me in the chat. Blue or green? Where should be the pi bond formed? Blue or green? What is going to be the major product? Okay, Hania. Okay, very good. Yes, Nabil, Khalid, correct. Waiting for others. Look at this criteria. Yes, very good, Minashi. Yes, Saifullah, very good. Chali. Yeah, nice, nice. Everyone is getting the right answer. Okay, Chali. So write these questions. Okay, write these questions. Write the products and send me. Okay, write the products and send me. Nabil, correct. Nabil Ahmed. Correct, correct. Correct, Khalid. Minashi, very good, correct. Heshma. Yes, very good, Heshma, correct. Glad. Very happy with you guys. Keep it up like this. Waiting for others also, then we have to start the test also now. Aaj test bhi hai. I hope you guys remember. Samara, your second one is wrong. Look at the criteria and tell me how you have done this. Hey, Salman. Salman, what question have you written for the second one? See the question
No,
that
I
you have
didn't.
written.
I didn't finish the figure.
Why? Why didn't?
I skipped it to the third one.
Why are you in such a hurry?
Yeah, I didn't notice. I didn't notice. My bad. Like
Okay.
the electricity
Sama-
went off, so I had to do something.
okay, okay, fine. Samaira, you look at the second one. You get it why it is wrong?
Yes, sir.
Okay, है ना? It will be from the red and green. There will be pi bond. Okay, just do it fast. Test करना है कि नहीं आप लोगों को? Okay. हानिया ने भेजा है. Okay, हानिया. Hania, why OH, huh? Hania, can you turn the mic on?
Yes, sir.
Why OH will be there? See, I have shown you, na? What happens when alcoholic OH reacts? It does not form alcohol, it forms only alkene. Alcoholic, it is not aqueous. Aqueous will form alcohol. दोनों में फर्क है, okay? Aqueous KOH is different from alcoholic KOH. Okay, remember this.
Yes, sir.
और फिर सेकेंड वाले में CH3 ही रहेगा, CH2 नहीं होगा. Structure that you have made, here it will be CH3 only. Why there will be CH2? वहां से हाइड्रोजन नहीं जा रहा ना, it is not going from that carbon atom. Okay, चलिए, that's it. Okay, I have given you enough time. Now let me show you the paper. So you should be there, na, Hania? Can all of you see the paper? Tell me. Just wait a second. Wait. I think it's better to open.
Sir, send the paper in group. It will be better.
See, Hania, आपने बताया भी नहीं कि आप नहीं आएंगी, ठीक है? Another thing, Hania, you did not even ask for the lecture. The lecture gets uploaded 1 day later. So yesterday, आप कल आप lecture ले सकती थी हमसे, and then you would have just saw the lecture, right, Hania? Tell me.
I saw the lecture just before the class.
Sorry,
I saw the lecture just before the class.
you saw the lecture just before the class, now.
Yes.
So what is the problem? Tell me.
I didn't have the time to revise.
No problem, just attempt this ना. ये boards नहीं है ना आपका. What will happen? ठीक है? Attempt this paper. What will happen? All of you can see the instructions, है ना? I have to also inform the next class that they will be having 10 minutes later.
Sir, can we start writing?
हाँ, you can start. Once I have showed you the push paper, you can start writing. और हम देखने वाले तो है ना कि आप लोग time तब से start होता. Time starts as soon as I start showing you the question paper. Okay.